Good day, viewers. Here's another question from motion. Now, this is projectile motion. Now, let's say motion is a common topic in physics, but most times you see learners having challenges understanding how to solve them. Now, I'm going to share an idea how I usually explain this to my learners. Now, the question says a ball is projected horizontally, very important, from the top of a hill with a velocity of 20 meters per second. If it reaches the ground 4 seconds later, what is the height of the hill? When you read a question like this, other than jumping straight to writing formulas, see if you can sketch. Now, I am going to try and sketch this. Here is the ground where you stand, and on this ground is this hill. Now, here is the hill, right? From top of this hill, you projected a board horizontally. You must understand the sense of this step. This word here, horizontally, means from the ground. This ball was not thrown vertically down, so it was thrown to keep going horizontally this way. So the first velocity is for horizontal motion, and the value was given as 20 meters per second. But you know that when you throw something from top of a building or a tree, it can never keep going horizontally. It's going to eventually fall down. Why is this so? Because gravity is going to definitely act on it. There's going to be friction between the object and air. So the object will eventually fall down. That tells us there are two movements, two directions the object moves. One is it moves horizontally, which was intention for throwing it. Second is it's going to eventually fall vertically down due to effect of gravity. So that means you must understand which aspect of velocity is for the horizontal motion, which aspect is for vertical motion. Which aspect of the motion do gravity affect? Of course, that is the vertical component. Okay. Now, the object moves from here until eventually falls. That time the object took to fall, t, is actually time of flight, and we're giving that as 4 seconds. The initial velocity with which the object was thrown is only for the horizontal part, so you can't use it for vertical motion. You can't use it. This is only for horizontal motion. Of course, we have acceleration g as 10 meters per second. Now we're looking for height of this hill. Now look, you have t, you have u, you have g, you have h, and that's what you're looking for. You can't use this u for horizontal projection if you are solving anything vertically. What does that mean? I'll take us back to this diagram. You see, from where I curved this, it means there was a time this object decided to fall vertically down, right? The initial vertical velocity here is 0. While the initial horizontal velocity is the one with which the object was thrown. So eventually, when the object falls here, it will have a maximum vertical velocity, which we are not looking for at this moment. So we realize that the initial vertical velocity is actually 0. Why is this important? The height of the hill is a vertical distance. So we can use 20, which is for horizontal motion, to solve it. Now you have initial velocity, you have acceleration, you have time. You're looking for distance. Which equations of motion can you use? You remember S equal to ut plus half at squared. Here this S becomes your height, equal to this u becomes initial vertical velocity, since the height is a vertical part, then multiplied by t plus half This A has to become acceleration due to gravity and positive because the object is falling down, which is the direction of gravity. So have gt squared. Okay, let's substitute. Y is 0 times 4 plus half times 10 times 4 squared. So half h equal to 0 plus this times this 5, half 5 times 16. So h is equal to 0 plus 5 times 6, 30. 5 times 1, 5 plus 3, 8. So finally h is 0 plus 8.